Hello, now this video is on second order differentials. Now I've got a bit of a treat in store for you today, because although second order differentials are notably a pure topic, and if you did your A-levels in the last kind of 5-10 years, then you'll know that second order differentials are pretty much in Further Pure 3 and that's it. But for those of you who are currently studying your A-levels this year, you'll know that you need to do something extra with them, which I'm going to do little bits of, which is of course use them with simple harmonic motion in what used to be called M5. Now, that makes life a lot more fun because you're effectively turning really fun differentials with physics, and that's always good fun. Or certainly should be if you're doing further maths, and if it's not, then I question your sanity. So yeah, anyway, here we are. My question today is d2y by dx squared plus 6 dy dx plus 9y is equal to 36 sine 3x. Now, whenever you have a second order differential equation, there's basically two things you do every single time. Firstly, you do your particular integrals. Secondly, you find your complementary function. Now, the complementary function is the dead easy bit, so we'll get that done now. Also, this is the bit that links quite nicely with the simple harmonic stuff that you'll be doing. So what we can do is we can rewrite this as m squared plus 6m plus 9 is equal to 0. Because the d2y by dx squared is effectively as an m squared, dy dx is m, y is nothing. So then we just have a quadratic. Now I'm assuming by this stage of your A-level you should be able to tell me what that's supposed to be, also the importance of it as well, because we can write this as m plus 3 all squared is equal to 0, which means that m is minus 3. Now, what this tells us is that there is only one repeated root. Now, the fact that there is only one repeated root is very important because it affects what our complementary function is going to be. And our complementary function with one repeated root looks like this. Y equals e to the minus, or should I say, y equals e to the m, a plus bx. So in this case, it's going to be e to the minus 3x, a plus bx. That's what our complementary function is. Now, if this question specifically was related to simple harmonic motion, and we got that from our pendulum, that would tell us that the pendulum is critically damped. Now, if we had two distinct roots, so we had, I don't know, I'm trying to pick one that we know will work. So if we said we had m squared plus 7m plus 6, then we know be m plus 1, m plus 6, then as you know we'd have two distinct roots there. That would be heavy damping, and if it's got complex roots it'll be light damping. This is kind of our brief foray into the world of simple harmonic motion. Basically, depending on your complementary function depends on the type of damping that is acting on the system, and that is particularly important. Anyhow, that's the easy bit. Now we move on to the slightly more difficult bit. Now, depending on what this bit is, i.e. the bit that's after the equal sign, depends on what you think your particular integral is going to be. For example, if it was 2x squared plus 3x plus 4, then the chances are your integral is going to be in the form of ax squared plus bx plus c. If you had it in terms of e, then your integral is going to be something to do with e. If it's with trig, it's going to be, well, I'm going to take a random stab in the dark here and say it's something to do with trig. So here we are. Now then, we don't know what's going to be before basically our trig expressions, so we're just going to assign them random letters of a and b. Now granted, a and b is crap because I've already used them, but I'm going to use a and b anyway. Now, as we have what y equals, we need to know what dy dx equals, which we do by continually differentiating. So in this case, this will go to 3a cos 3x minus 3b sine 3x. And again, we can find the second one as well, d2y over dx squared, the second derivative, second differentials, as minus 9a sine 3x minus 9b cos 3x. Now all it is a matter of subbing it into the original question and then doing a bit of rather fun algebra in this world. So here we are. What we have is minus minus 9a sine 3x minus 9b cos 3x plus 6 lots of 3a cos 3x minus 3b sine 3x plus 9 lots of a sine 3x plus b cos 3x. I'm sorry this is going off the paper a bit, but you get my point, is going to be equal to 36 sine 3x. Now, as you can probably guess by the fact that we have a minus 9a there and a plus 9a there, you might get some things that cancel a little bit. And so we can basically ignore the stuff for the y and the stuff for the d2y by dx squared. As you can see, I've drawn a slash through it, simply because we know that minus 9 and 9 will cancel and minus 9b and plus 9b will cancel. So what we're effectively left with is, we're left with 18a cos 3x minus 18b sine 3x is going to be equal to 36 sine 3x. Therefore, minus 18b is equal to 36, b equals minus 2, and as there's no cos's on one side, we know that a is 0. This is quite helpful because this will actually tell us what our particular integral is now, which we know to be y is equal to minus 2 cos 3x. So therefore, putting it all together will be y equals e to the minus 3x a plus bx minus 2 cos 3x. Now that is effectively your solution. Now maybe in later questions you'll be asked to keep differentiating and find what the values of particular derivatives were, or you might be asked to use it with Maclaurin's and find that, or you might be given some values and said, you know, if I differentiate, what's the value of x when it tends to infinity, blah 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 blah. But that is not something I will cover today, maybe later. See you all soon. Bye.